with these guys right here. The most important part about any question that deals with quadratic equations is, Bradley, is the names of the people and the two boxes that you're working with. So what I want you to notice here is that there is Joe, Sally, and Raj. Okay? Those are the three people involved in this question. There's also two boxes. There is a solar pool cover and there is a mesh net. So here's the thing that I want you to think about. These three names, those two boxes, you're only going to be working with like one combo at a time. Joe and solar, or Joe and mesh, or Sally and mesh, or Sally and solar. You're never going to be doing like a combination of any of that kind of stuff. And so that's the most important thing to note. The second most important thing to know is like, what is X for solar, right? What is X and what is Y for both of these, right? Knowing what X and Y is for either solar or mesh kind of guides your actual focus in this one. So for solar, it's basically saying radius of the pool in meters. So radius of pool. X is the radius of the pool. X is also radius of pool for this guy here. So what's important about that is if I use this the equation for, or the rule for solar, and I figure out the size of Joe's pool's size is not going to change whether I'm using this block now or this block here. Okay? So the only thing that's different is that for Y, it's going to be cost of like solar cover. And Y here is cost of mesh net. Okay? If you kind of write this stuff out or like highlight this stuff before you get started, it's going to make your life a heck of a lot easier when it comes down to actually solving this stuff. Okay? So from there, let's now take a look at what this question entails. So the first bullet point, I just want you to go through like bullet points. It says three things that are important on the first bullet point. It says solar, it says Joe, and it says like a cost of $110.25. If I break down that first bullet point to what's important, those are the three things that are important. So here's why that matters. Y, A, X. I always like to label stuff. If I go to look at the box for solar, I know that I already have an A for this one, and it's 9. If I look at the value they gave me, $110.25, well, that's a cost of solar, so that's a Y value. So now I know a Y value, I know an A value, so that means I'm looking for the size of Joe's pool. If that makes sense, that's pretty well about as hard as this gets. You just basically do this same thing every single time. New bullet point, plug in what's missing, and you'll see kind of shaded out behind here what I already erased. You just go to your memory aid and go, how do I solve for an X? Right, divide first, then square it. Done.
So much.
Or square root it. What?
That helps so much.
Yeah, it did. It made a huge, yeah, you're totally right. That was your idea. That wasn't my idea. That was Yanni's. So basically from here on in, now that I've identified it, this is the rule I'm working with. I know I'm solving for X, so 110.25 A, or 9, X squared. My memory aid says I will divide first, and it's something like, where did I put my calculator? In my back pocket.
It's 12.25, and then when you square root, it's 3.5.
Perfect. So 12.25, and as you said, so I divide first, then I square root, so X is, you say 3.5?
Yeah.
Okay. So now that's done. Once I've used the 110, and I'm going to say this twice because I know my voice drones on and is relatively boring. Once I've used 110, okay, you will not use it again. You can cross it off. That bullet is kind of done with us now. We don't need to concern ourselves with it anymore. So we literally just go look at the next bullet point. And it says meshnet. So I'm going to be working in the meshnet box this time. It still says Joe, so that's helpful. And then it gives me a cost, $85.75. Okay, so mesh Joe $85.75. Let's look through this here. Y, A, X. $85.75 is the cost. So I have a Y. If I look in the box for meshnet, it just says like y is equal to ax squared. So it's just telling me that we're working with a quadratic function here. But I don't know what a is. Now here's the only weird part about these guys, and why it's good to kind of think about it logically. Joe's pool is 3.5, has a radius of 3.5 meters. I know that because I just solved for it here. Typically that's going to be what happens. Whatever you solve for on the previous bullet should be involved in the next bullet. So now it's missing an a value. This is the function I'm using. I'm just going to plug things in and solve for it. And then, I am looking at my memory aid and knowing that I'm going to square it first. And then I'm going to divide and see what I get here. So something along the lines of 12, 7. So a is 7. And again, if I solve for a is 7 on this guy, you better believe I'll be using him on the next one too. It's just kind of the way this guy keeps working. Feel free to ask any questions along the way. So far, so good in terms of this making sense. I just want to pause for a second. Yeah. Okay. Give you a couple seconds to write that down, then we'll look at the next part here. So continuing on here, I'll write out the next bullet point. It says meshnet, so I'm still sticking with mesh. It then says Sally, so we've got a new name now. What's important about that, and I'll underline that a few times, is that now we don't know the size of Sally's pool. Hers is not going to be 3.5. That was Joe's pool. So in terms of, that's like the logic that has to kind of be brought into this a little bit, is that we now need to know is a different name, obviously different pool. Okay? New year, new Sally. No? I'll see myself at it.
Sure, I'm going to guesstimate it's 11.5 DA.
Nice. So, well, we have this guy here. We have both A's. We have the A here and we have the A here, so it's not going to change on this one. We're going to find the X on this guy because it goes the Y. Oh, to the size here. The Y value on this guy is 141.75 because it's a cost, right? Cost is always Y. The A is what I just found. That is always transferable. Question, yeah?
Why is A transferable?
So that's the rule. So when I had it up over here, right, once I find it for meshnet, okay? So y is equal to ax squared. You have the rule when you have a. Because we found the meshnet a, any other time we go do a meshnet question, the a is going to be 7. Whenever I do a solar pool cover question, a is going to be 9, right? That's a really good question. It kind of defines what the cost is going to be, right? If you look at it right now that you know that the a is 7 for meshnet and the solar has a value of 9, what is going to be more expensive depending upon the size of your pool? The solar or the mesh? The solar is because the a is 9. It's a bigger number. I'm multiplying it with like the same x squared. So no matter what, I know my solar is going to cost more because the A is bigger. So essentially it kind of dictates like an increase in cost more so than anything. And usually, as of late, they've been keeping these questions like financial. So it's like as A gets bigger, the cost gets bigger. These can be used in other scenarios to kind of track stuff, but it's a lot easier to make sense of it when it's like cost, because you can kind of see A bigger, cost bigger, right? Like it's a way to understand it better. But all that to say, Sally Mesh 147, A is 7, X in this case is unknown. It's a new person. I don't know what the size of her pool is. I still know I'm working with this guy, 141.75, 7, X squared. Only thing I don't know is the X squared. We divide first. X squared is equal to something. I think you had it on there, but let's get the 141.75 divided by 7 is 20.25. So then X is going to be
4.5.
Yeah. 4.5. So that's the size of Sally's pool. Again, I will not use this 85.75 again. I will not use this 141.75 again. I just can't. Okay? So the last bullet point, or one of the last, is suggesting that the radius of Raj's pool is 1.25 meters larger than the radius of Sally's pool. Now, this is an important part of it because we were talking the other day there about this Yanni. Because X says radius and because that one says radius, we're just going to add the 1.25 to this. Right? So for this next thing here, we can say, all I know is that Raj's pool, the only information it gave me is 1.25 bigger than Sally. Right? So for this, I'm just going to go 4.5 plus 1.25. This isn't, we're not doing any kind of weirdness or any kind of crazy calculations. We're just going to be adding these two things together. It was 1.25, right? So 5.75 meters. That's the size of Raj's pool now in this case. Okay, that's all I had to do for that. And then at the bottom it says, how much does a solar pool cover cost for Raj's pool? So last thing was Raj, solar, and unknown cost, which means I'm looking to solve for a y, is all that's suggesting, okay? So we now can write down y, a, x. Well, the size of Raj's pool is 5.75. The A is still 9. That didn't change from the very beginning of the question. This guy all the way over here in that box, A is equal to 9. Does not change, still exists right there. A is transferable. Okay? So I'm looking for a cost given this information. So let's plug it into the equation. Y is equal to 9, 575 squared. So memory aid says square, and I get, you can do this all in one if you want. I'll break it into two parts. And so times 9. So y is equal to $297.56, and then that's it. There's your final answer for a guy that looks like this. Now you'll see, I really should use the chalkboard more. Why I prefer the chalkboard in this, because you can kind of see the whole rundown of it. But that is quadratic equations in a nutshell.